Alright, so a lot of this, there's quite a bit of this district checkpoint review that I'm going to do. You are going to turn this in to me the day that you take the district checkpoint review, because it's going to be used as a type of grade or a type of extra credit. I haven't quite decided, but you are going to turn it in, and it's something that would be beneficial to you. So I encourage you to do it, and also to do the problems that I don't do. Okay, so the very first one, number 1, okay, is talking about they want you to find the angles 1 and angle 2 in circle P. Well, when you look at this, you got to figure out what type of angles are angle 1 and angle 2. First of all, isn't angle 1, isn't that an inscribed angle? Because its vertex, the vertex of angle 1 is on the edge of the circle, right here, right? And then angle 2, well, where's the vertex of angle 2? I mean, it's inside the circle, but isn't it at an exact spot? Yeah, it's in the center of the circle, so it is a central angle. Well, when I know what type of angles I have, then if I know their intercepted arc, I can find their angle measures. So when we look at this, they they give you this arc measure right here that I just shaded in blue. They tell you it's 145 degrees. Well, isn't that arc the intercepted arc of both angles? Okay, in other words, isn't angle 2, this angle here that I'm highlighting in red, isn't that angle, that central angle, isn't its intercepted arc the blue arc that is 145? And when I have a central angle, the central angle and its intercepted arc are equal. Well, since my arc equals 145, then that means that angle 2 equals 145. So I'm halfway home. Now I'm going to do angle 1. Well, angle 1 is an inscribed angle. And remember, an inscribed angle is equal to half its intercepted arc. Well, the arc is 145. The arc is the same arc. Look, when I kind of highlight the sides of angle 1, well, they're intercepting the same arc as angle 2 are. So the arc measure is the same measure. It's just that the angle, the inscribed angle, is only half of that. So how can I find the measure of angle 1? Don't I just divide 145 by 2? So to find angle 1, you would go 145, and you would divide it by 2, and you would get 72.5. And so that is what angle 1's measure is. Okay? So we're moving on down to number 2. Now, number 2 is a problem that we haven't, or a section we haven't gotten to. Okay? And it's talking about a standard equation for a circle. But it's really, really easy. First of all, when you look in the directions, they tell you what the standard equation of a circle is. And this is the formula for this standard equation. And they talk about notice this ordered pair called H and K. Your H and K, that is the points, that is where the center of a circle is located at, and it's called HK. Well, the H represents the X coordinate, and the K represents the Y coordinate of the center. So, I'm going to use red for X, so the H is my X value, and I'll use blue for the K, and my K is the Y value for the center. This tells me where the center, what point the center is at. So, but I can't use another X and another Y, so I'll use HK when I'm dealing with a circle. Okay? So you're still plotting the points on a graph the same. Okay? And then in this equation, you let the radius equal r. So when you look at this equation right here, and I'm going to write it bigger right here, x minus h. And again, remember what h is. H is the x value of the center of the circle. So x minus h squared plus y minus k squared. Well, remember what k is. K is the y value of the center of the circle. And so when I use the x and the y value for the center of the circle, those points, those coordinates, those are my h and k. H is my x, k is my y. And then it's equal to whatever the radius is squared. Well, they just want you to write an equation. They don't want you to solve anything. They don't want you to do anything fancy. They just want you to take the information that they give you and write it in the standard equation of a circle. Well, let's look at our values. They give us the center of the circle right here. And I'm going to switch to red. This is this coordinates for the center of the circle. Well, isn't that negative 2, 4? Isn't that my hk? Isn't my h is equal to negative 2 and my k is equal to 4? And as you read this sentence, they also right here, they tell you what the r is. The r equals 4. So all we got to do is plug stuff in. Well, x minus the h value. We just said h is negative 2. Well, what's going to happen when I plug in negative 2 and I already have a subtraction sign? What's subtract negative happen? That's right, I get a plus. So my first part is going to be x plus 2 plus my y. Well, look at my k value of the center. It's positive 4. So I've got minus 4 squared. And then I've got the radius squared. Well, if I take 4 right here and square it, what is 4 squared? It's 16. And so this whole thing right there, that is my answer. That is written in the standard equation of a circle. Okay? All right. So now the next one, number 3, it says accompany a diagram of a circle. They tell you that the diameter AB is perpendicular to CD. And then they tell you what CD equals, and they want you to find CE. Okay? Well, I'm going to use some colors first. I'm going to use a marker. Okay? Alright. So, AB, here, my blue highlighted mark, or red mark, excuse me, that's my diameter. So, AB is my diameter. And CD is in blue, and that's my chord. Well, anytime a chord bisects a diameter, the diameter acts as a perpendicular bisector, meaning that at this point of intersection, it's making 4 right angles, and E is the midpoint. Well, if E is the midpoint, that means that CE is equal to whatever ED is. Well, and they give us one other piece of information. Right here they tell us that CD is 14. Well, aren't they talking about the whole chord is 14? And the two parts equal each other. If the whole thing equals 14 and the other two parts, aren't those the other two equal parts, CE and ED, aren't they half of the 14? So 14 divided by 2, and so CE equals 7. Okay. Now on the next one, number 4, I want you to do number 4, okay, because that's stuff that we've just finished doing. Okay. Now, for whatever reason, the diagram or the figure that goes with number 4 is on the top of the next page. So you'll have to take that, but just to make sure, I'll go ahead and try to draw the object, but it is on the very top of the second page. But they give you a circle. Okay. It looks something like this, and at this point you have C, here you have A, here is B, then the center of this circle is O. Okay, and so then they give you you have the same diagram on the next page, but that diagram that I've just drawn goes with number 4. So do number 4 yourself, and then you might want to pause the video as you work it, and then once you're finished with number 4, then go ahead and move on to the next problem. And there you go. You can see this is, again, that is the diagram that goes with number 4 that you were supposed to do yourself. All right, so now number 5. Well, number 5 is another problem that's dealing with a diameter that is bisecting a chord. And again, anytime a diameter bisects a chord, it's perpendicular to the chord, and it's also a midpoint. Well, let's look and see what they want us to do. They give us some information. First of all, they tell us from A to O, this distance right here, is 10. Well, isn't that the radius? So AO or OA, that equals 10, and that is the radius. Okay. We just kind of need to remember that. And then they tell me that BE, that is this section here that I'm kind of doing in blue, that section equals 4. And they want us to find CE. I'm going to underline in red what they want us to find. They're wanting us to find this piece right here. Okay, well, there's a lot of ways we can do this, but I'm going to use a right triangle. Okay, so what I'm going to do is I'm going to go ahead and connect. I'm going to get some different colors here. Okay. First of all, when I draw this kind of gold or yellow gold line right here, isn't that a radius? So isn't OC equal to OA? Yeah, it is, because the radius is the same in the same circle. And also, when I connect O to D, isn't that also a radius? So I've got 10 there, I've got 10 there. Okay? And I want to go back to blue real quick, and we know that this little piece from B to E, that equals 4. Well, some things that I'm missing. Let me ask you a question. I'm going to go to one more color. I'm going to go to green. Okay? Isn't this piece that we know is 4 and the other piece that goes to the center circle, isn't that the radius? So isn't OB also 10? So we know that from E to B is 4. So isn't there a way that we can figure out what that little piece is that I'm shading in red? The whole thing has to be 10 because the radius is 10. I'm not using this part. This part right here that I just circled in red, that is 4. Well, how much is left? What does OE equal? Well, it equals 6, because 6 plus 4 is 10. Well, so you got to realize what you have, what I've just made. I'm going to make a drawing over here. Okay, that is point E, that is C, and that is the center O. We know that this is 10. Okay. We know that this is 6 because that's a piece of the radius that we just subtracted from 10 from 4. The piece they are wanting us to find is CE. But what did I just draw? What type of triangle do I have right there? I have a right triangle, right? And don't I know two sides of a right triangle? One of the sides of this triangle is 6 and another side is 10. Well, if I know two sides of a right triangle, can't I find the third and remaining side by doing one of my equations, one of my rules? That's right, the Pythagorean Theorem. So, the Pythagorean Theorem says a squared plus b squared equals c squared. And remember, your a and b are your legs. Well, the 6 and the x are my legs. So, I'm going to plug them in, doesn't matter which. So I got my one missing leg that is x, so I'm going to square it. I have another leg that is 6, I'm going to square it. And then my hypotenuse, or my C, is 10. I'm going to square that. Okay. Well, 6 squared is 36. 10 squared is 100. Now I just got to solve. Subtract 36. And I'm going to switch colors because that green doesn't show up greatly, does it? So now I have x squared equals 64 because 100 minus 36 is 64. Well, how can I undo squaring? How can I get x by itself? Take the square root. Excuse me. And I had to take the square root of both sides. Well, the square root of x squared is x, and the square root of 64 is 8. And so my missing part, CE, equals 8. Alright, I want you to do number 6. It's done just like the problem that we just did. I'm just going to tell you right now, you're going to solve this one. You are going to have to do the Pythagorean Theorem. Oh, sorry about that. Technical difficulty. You're going to have to do the Pythagorean Theorem to find the part they want you to find. But you're going to do number 6 on your own. And you're going to do number 7 on your own as well. Now number 7 has to do, the diagram for it is on the page, it skipped to the top of the next page, but I'll go ahead and draw it on here for you and give you kind of a hint. But what you have is you have this circle. This center of the circle is O. Then this thing right here where A is, that is the radius that I just drew. And then I'm going to connect this all the way out here to point P. And then right there, and A is the point of tangency. Well, there I'm going to give you a little heads up. When one of your lessons you learned about this, and what you learned is that anytime I have a tangent line AP, this is a tangent line right here because it's only touching the circle at point A. Anytime a tangent line connects with a radius, and this right here that I'm shading in red, that is my radius. Anytime a tangent line touches a radius, it's perpendicular, where it makes it so. What type of triangle do I have? A right triangle. I bet something that you guys have learned with the right triangle is how you're going to find this missing part. So do number 7 and number 6 yourself. And there's the diagram, which I went ahead and drew on with the problem on the last page. All right, problems 8, 9, and 10. Well, I'm going to do these 3 problems because I haven't gotten to this. And we just kind of talked about the standard equation on the previous page. Remember what we talked about earlier, that the standard equation for a circle, the standard equation for a circle, and I'm not going to write the word circle, I'm going to use the symbol, is x minus h squared plus y minus k squared equals the radius squared. So what they want you to do is they want you to take these 3 graphs, 8, 9, and 10, and they want you to match these circles with these 3 equations. A goes with that choice, C goes with that choice, and B goes with that choice. Well, all you got to figure out is what are the coordinates of the center and what is the radius. Well, I'm going to use red to locate the center. Right there's the center of that circle, right there's the center of that circle, and right there is the center of that circle. Okay, so all I need to do is figure out what are the coordinates, what is the x and y value. Well, let's look at this first one right here. This one right here, number 8. Isn't my x value at 3? And then my y is nothing, so it's 0. Isn't that right there, 3, 0? Isn't that the HK or the center? Okay. Well, if I plugged 3, 0 into my standard equation, well, wouldn't I have x minus 3 squared, and my k is 0, so is there any reason to go y minus 0? Nope. So y squared, and then the radius, well, how did we figure out the radius? Well, don't we just count for right there? Isn't it just 2? And so the radius is 2, or 2 squared. What is 2 squared? It's 4. So which one of these choices here, A, B, or C, goes with number 8? That's right. This one right here goes with number 8. So number 8 is B. I want you to have some practice. I want you to do the next two, number 9 and number 10. Figure out which one of those equations goes with 9 and which one goes with 10. So do number 9 and 10 yourself. Alright, now this was some stuff that you guys did while I was gone, and you guys struggled. Don't struggle. The first thing is, when you do these problems, anytime you see the word angle of elevation or angle of depression, take the word problem and draw a right triangle, because whatever they're talking about in here, the things are making a right triangle. Okay. Well, let's do number 11. Okay. So it talks about a plane is leaving the airport. So here's my plane, and it takes off and it leaves the airport. Okay. And it says when it leaves and it takes off from the ground right here, there's my ground. But when it's taken off, it has an angle of elevation of 31 degrees. So my angle, 31 degrees, goes right there because my plane took off. After flying for 42 miles, so once the plane took off the ground and went in this direction, it traveled 42 miles. Okay? They want to know how far is it from the airport. Now remember, this is where the airport is. This location right here is representing where they are when they're over the Cowboy Stadium. Okay, and it says how far is it from the airport to the stadium? Well, isn't that this distance right here from A to C, from the airport to Cowboy Stadium? And this right here, that would be my height. So doesn't that mean my right angle is right here? Well, look what I made. From the word problem, I made a right triangle. Now, we just did a bunch of stuff with the Pythagorean Theorem, but to use the Pythagorean Theorem, you have to know two sides. We only know one. We only know that that's 42, and we know the angle measure. Well, anytime you know an angle measure and just a side, you have to use your trig. You have to use sine, cosine, or tangent. Okay? Well, and which one of these three you use depends on the information that you are given. Well, this 42 miles, isn't that the hypotenuse of the triangle? And this is a leg. Well, but we have to figure out what leg is it. Is it the adjacent leg or the opposite leg? Well, here's my angle that I'm dealing with. So isn't this side here that they want us to find, isn't that the adjacent side to the 31 degree angle? Adjacent means it's sharing something. Isn't it sharing the vertex making that angle? So this is my adjacent leg. Well, which one am I? Remember your SOHCAHTOA. Some sine is some old hippie tripping on acid. Okay. Well, cosine is the adjacent over the hypotenuse. So I set this up. I have cosine of a 31 degree angle is equal to the adjacent leg, which is x, over the hypotenuse, which is 42. And if you remember, anytime the missing part when you're doing a trig ratio is on top, that means you're going to multiply 42 times cosine 31. Now before you do this in your calculator, I noticed this when I graded some stuff, you got to make sure that your calculator, whether it's a calculator on your phone or one of the school calculators, you got to make sure that the mode is in degree mode. Make sure you are in degree mode, because if you're not, your answers are going to be wrong when you're using sine, cosine, and tangent. They must be in degree mode. Okay, so always check that. Okay. Matter of fact, I did that on one of y'all's lessons in the very beginning, and didn't have the for a couple problems didn't have stuff in degree mode. Okay, so anyway, I plugged that into my calculator. 42 times cosine 31, enter, and what you get is, I get 38.4 if I rounded it to the nearest tenth, but look what they said, to the nearest mile, meaning the nearest whole number. Well, is 38.4 closer to 38, or is 38.4 closer to 39? It's closer to 38, and so the answer to number 11 is 38 miles. Well, I want you to do number 12. on your own. It's the same type of problem. It's exactly the same type of problem. You've got something that's talking about an angle of depression, so you know you got to make a right triangle. Okay? Alright, so do number 12, and then once you complete that, then we'll go ahead and go on in the notes. Okay. Number 13, finding the perimeter of a square. Well, first of all, how do you find the perimeter of an object? You add all of its sides, right? Well, what I'm going to do right now, I'm going to just start off by drawing a square. And let's remember what a square does. If an object is a square, it has 4 congruent sides, right? It also has 4 right angles. Okay. So it says find the perimeter of a square if the length of the diagonals, there's my diagonal, the length of the diagonal is 16. Well, now let's round our answer the nearest tenth. Well, what I'm going to do is I'm going to go ahead and take apart my square. Equal side, there's my right angle, and the diagonal is 16. Now, this angle here that I'm circling in black and this angle here that I'm circling black, remember originally those two angles at one point were right angles. But when we draw the diagonal, don't they get bisected? And if something is bisected, doesn't it cut it in half? Well, what is half of 90 degrees? It's 45. So that means this angle here is 45 degrees. And this angle here is 45 degrees. This is a special right triangle. And if you remember, in a special right triangle, that the hypotenuse of a 45, 45, 90 is found by going x, whatever x is, whatever the short leg is, times the square root of 2. In other words, 16 equals x square root of 2. So, in other words, when we come down here where stuff isn't cluttered, 16 equals x times the square root of 2. Well, in other words, if I knew what x was, when I multiply the square root of 2 to it, it equals 16. Well, that's what I need to find, because this right here, x, that's what these missing parts equal. And once we find what these missing sides equal, then I can find the perimeter, right? Because perimeter, we add up all 4 sides. Right? So that's what we need to figure this. So we're going to solve for x. Well, what is the square root of 2 doing to x? It's multiplying it. So we'll divide. We'll divide both sides by the square root of 2. So that disappears. We're left with x. But if you remember, when we started dealing with square roots, we can never have a square root as a denominator. The square root can't be in the bottom of a fraction. So to get rid of it, I go the square root of 2 over the square root of 2, because when I multiply straight across, the square root of 2 times the square root of 2, I'm going to have to move over here. The square root of 2 times the square root of 2, isn't that just 2? Remember, anytime you multiply a square root times itself, you get rid of the square root and you just keep one of the numbers. So we're just going to keep 2. And then 16 times the square root of 2 is just 16 square root of 2. Well, for now, just put your thumb over that square root of 2. Well, what is 16 divided by 2? It's 8, right? So I'm left with 8 equals the square root of 2. Well, now remember now, that's just what each one of these sides equal. Each one of these sides equals 8 times the square root of 2. 8 times the square root of 2. So couldn't I go 8 square root of 2 plus 8 square root of 2 plus, I could do that 4 times, or wouldn't it just be easier to go 8 square root of 2 times 4? Okay? And you could do that, but they did ask us to round the nearest tenth. So this is what I'm going to do. I'm going to go ahead and go 8 times the square root of 2 in my calculator. When you did that, you should get, it's 11.3 if I round it to the nearest tenth. It's like 11.31. Well, that's just what one side is. Well, I have 4 of those, so I'm going to go times 4. And when you do, when you do 11.3 times 4, something didn't add up right. Hang on 1 second. The first time I did this, and then I look at my paper, that does not make. Just 1 second, please. I just noticed a little mess up that I had, and so I'm wanting to make sure I fix it. Okay, and so what I get, I've got it fixed now. So 11.3 times 4, I get 45. Okay, 45.2, I believe. And so that is the perimeter of that object. Okay. All right. Well, I want you guys to do number 14. Okay. I want you to do number 15. Okay. And I want you to do number 17. So that brings us to number 18. Now, we didn't spend a lot of time on the geometric mean. Okay. But there's several ways to do it, but this is the way I like to teach it. I want you to look at the drawing right here that goes to number 18. You got to realize that there are 3 different right triangles here. You have your large one, and then you have your 2 smaller ones. You have this one on the left, I'll give it an L, and you have the one on the right. But there's 3 total right triangles. And some of these parts that they give you, they are different parts. For instance, 9 isn't 9. It is, for the little triangle on the left, it is the shorter leg, okay, of that triangle on the left, and X is the long leg. And for the triangle on the right, the X is the shorter leg, and 16 is the long leg. So what we're going to do is we're going to set up a ratio. And so we're going to take our shorter leg, which is 9, over what is our longer leg, which is X. So we have short over long in the same triangle, right? And then I'm going to make a proportion, and I'm going to do the same thing. Well, I need to make sure that I stay short over long. Well, so now let's go to the triangle on the right. Well, which one of the legs appear to be the shorter leg, X or 16? X does. And so that means 16 would have to be the longer leg of that right triangle. And so now I have a proportion. And when you set these up doing a geometric mean, you should always have it set up to where when you cross multiply, you get the same thing being multiplied to itself. So X times X is X squared. 9 times 16 is 144. Get X by itself by taking the square root, and you find that X equals 12. Okay? Okay? Now, I'm going to do number 19, because it's another geometric mean, but you will do number 20 and number 21 because you are going to use the Pythagorean Theorem. But what's going to help you is once we do number 19, that will help you to do the following 2 problems yourself. But anyway, it's a geometric mean problem. So let's look over here. They want us to find X using the geometric mean. So notice again, there's 3 total right triangles. You have your big right triangle here, okay, and then you have your smaller 2 triangles. You have this triangle here that's on the top, and you have this triangle here that is on the bottom. And this side that is X, it is a leg, okay, it is a leg of both of those smaller triangles. Okay, well, for the bottom triangle, if you looked at these, doesn't this right here look like it's the shorter leg and the X is the long leg? And then when I go to the triangle on the top, this leg appears to be longer and this appears to be shorter. So I'm going to make a proportion. So I'm going to go short over long and short over long. Well, we'll do triangle on bottom. Again, remember we said that 3 was the shorter leg, so we'll put 3 on top. and x is the other leg, so it goes on bottom, and that's the longer leg. We'll go to the triangle on top. Well, the triangle top, the shorter leg is x, and the longer leg is 27. And if you remember a while ago when we talked about anytime you do a geometric mean, I should have that situation when I cross multiply, I'm doing the same thing times itself, and I am. I'm doing x times x, which is x squared, and 3 times 27 is 81. Take the square root of x, and I find that x equals 9. And so now I know what x is. X equals 9. Now you will do this problem to find the rest of your information. I'm going to give you a hint. When you go to find y, since you can't use the big triangle, what you have to do is look what you do. You know that this is 3. We just found what x was. Well, aren't these two sides of a right triangle? Okay, 9 and 3. So isn't that what you would use to find y? And then when you go over here to do this other triangle, same thing. You'll know more information to be able to find that one. Okay, and when you do 20 and 21, you can either round you can put your answer to the nearest tenth. Okay, nearest tenth, or you could leave your answer in simplest radical form. On your test that you will take, they're going to go back and forth. One time it's going to be rounded, next time it's going to be in simplest radical form. So now I would go ahead and round to the nearest tenth, and then I would try to attempt to simplify the radical, just to do it for practice. Okay? All right, well, I hope this was helpful. You're going to get a certain amount of points for writing down everything that I did, and you're going to get a lot of points for attempting and a lot more points for getting problems on your own correctly.